My dear students, we have studied about encoders. So we will recollect what exactly the encoders are. Then we will look for what is the need for priority encoder. Then we will proceed with how priority encoder can be designed. Okay. So let us recollect what exactly encoder is. So just reverse operation of decoder itself is encoder, as we aware. There in decoder, you will be having n inputs, 2 power n outputs. Whereas in encoder, you will be having 2 power n inputs, 2 power n inputs, okay, and n outputs. So here n is equals to 2, 2 power 2 is 4, so 4 is to 2 encoder, okay. So when input is 1 0 0 0 0, output is 0 0. When input is 0 1 0 0, output is 0 1. When input is 0 0 1 0, output is 1 0. When input is 0 0 1, output is 1 1. So now what exactly happening is at any instant of time, only one being 1. That means only one of the input is 1. This is the case. Let's suppose if all the inputs are 0, output is also 0 0. This is an issue for us. Whether it is saying whether all the inputs are 0 or whether it is saying whether d is equals to 1. Whether it is d1, whether the input is 1 0 0 or 0 0 0 is a big question mark. Okay. Now if then more than one inputs are 1, let's suppose when d2 is 1, d1 is also 1 and d0 also 1. Okay. This is not going to give the proper output. So this is the problem in or issue in encoder. To resolve this issue, we are going for priority encoder. Priority encoder. So in this priority encoder, if at all you look at, we are trying to solve all the issues whatever we are facing in normal encoder. What are the issues that we have? Yes, we have an issue when all inputs are 0. Okay, outputs are 0. When D1 is 1 and rest of the inputs are 0, then also we are getting outputs are 0. Now, what we are trying to discriminate these two by having a valid bit V, we are saying that the output is valid or invalid. When all inputs are 0, these outputs are also 0, okay, along with the valid input, there is a valid input. So this valid output actually is not input, it's output. Valid output says that the whatever the output that are available on the output lines is not valid. That means you are not supposed to consider when output is 0 0, input is D0 is 1. No, you can't consider because valid bit is 0. If valid bit is 1, that means it is a valid output. That means 0 0 output is invalid or valid. 0 0 output is invalid when all inputs are 0. Okay. 0 0 output is valid when input is 1 followed by 3 zeros. That is when D0 is 1 and rest of the inputs are 0. We are saying that is valid. That means output which is 0 is a valid output. So output 0 0, that is output 0 0 may be valid one, may be invalid one. Invalid if all inputs are 0, valid if D0 is 1. Okay. So when D1 is 1, we are designing this encoder in such a fashion that the meaning of this is D1 is having highest priority. Doesn't matter the value of D0, whether it is 1 or 0, doesn't matter. We are going to get output as 1, saying that there is a D1 line is active. Okay, whatever may be the input on D0 doesn't matter, which means D1 is having highest priority compared to D0. Okay, rest all are zeros, that is D2 and D3 input lines are zeros. Now if you look at this input combination, D1 when D2 is 1, doesn't matter D1, doesn't matter D0, that means D2 is highest priority compared to D1 and D0. Whatever may be the values of D0 and D1, if D2 is 1, D2 means 2, 2, 1, output is 2, saying that D2 line is 1, D2 input line is 1. What is the meaning of this, if at all you want to look at? When D3 is 1, doesn't matter D2, doesn't matter D1, doesn't matter D0. That means D3 is having highest priority. Okay. So now when there are 4 inputs, what are the possible combinations? 16 possible combinations. Okay. So all 16 possible combinations are covered here. Right. So what I need to do? I need to enter these values into K-map so that I am going to get expression for X, expression for Y, expression for V. Why? X is function of D0, D1, D2 and D3. What about Y? Y is also function of D0, D1, D2, D3. What about V? V is also function of D0, D1, D2, D3. Right? So in this way, what we can do is we can use K-map, then we can find the values of X, Y and V. Okay. So if you look at the expression for X, okay, so D2, D3, D0, D1 is being given, enter the values. Now what exactly the case? I can add these two, combine these two, 8, or I can combine these 8 ones. Okay. Now MSB D2, D3, D2, D3, then D0, D1. Okay. Is that fine? Generally in our K-maps, what we try to do, we write D0, D1, D2, D3. So how the numbering will be here? This is least significant or most significant? Most significant. What about D2, D3? Least significant. The order in which we have written is D0, D1, D2, D3. So these are LSBs. This is MSB. So this is MSB. So LSBs are changing in this direction. So this will be 0, 1, 3, 2, then 4, 5, 7, 6, 8, 9, 11, this is 11, 10, 12, 13, 15, this is 15 and this is 14. Likewise the next. Okay. So now if you refer back to the table, here. Okay. For how many cases it is being 1? X is 1 for 4 cases. This 4 cases. So this is 4 cases. Why 4 cases? Don't care. Means this can be 0, 0, 0, 1, 1, 0, 1, 1. That will give you 4 ones. What about this single one? It looks like single one, but it is 4 times 1. This looks like single time 1, but when I expand this from 3 zeros to 3 ones, it will give you 8 combinations. So 8 plus 4, how many? 12 combinations. For 12 combinations, I have X being 1. Okay. What about this? Y? Y being 1 for 8 combinations. Y being 1 for 2 combinations. When X is equal to 0, X is equal to 1. Okay. So 8 plus 2, 10 combinations, 10 ones in Y. Okay. And what about X? 12. 8 plus 4, 12. What about V? Here 2 cases. Here is only 1 case. Here it is 4. Here it is 8. Okay. That many ones will come in V table. Okay. K-map. What is there is, what exactly that we have written, don't care here. It will give you 8 ones because this is what exactly the combinations. Okay. Or in K-map you can look for what is D3. What is D3? When you will get D3? Here it is D2. Okay. So once you enter into the K-map, right, you will get the values for X, values for Y. Okay. So is it not D2 plus D3? Yes. What about Y? Can I do like this? Yes, for sure, right? So is there any other possibility to do any other things? Okay, what is this value turns out to be? Is it not D2? Can I make this as like this? Okay, is there any other possibility? No other possibility. So what is this exactly? From this, what exactly you are getting? D2 bar, D2 bar. From this, what you are getting? D1, right? So D2 bar, D1. Similarly, V. Similarly, table for V, we can do it, and we are going to say, or we can say it is a combination of, it is 1 when D0 1 or D2 1 or D3 1. So if any one of them is 1, this is 1. That we also we can do it, or we can use K-map. Okay. So on the whole, we will get the same. So with this, priority encoder design is done. So far we know priority encoder. Priority encoder is having 4 inputs and 3 outputs. What are 3 outputs? X, Y and valid output. Okay. Y valid output. If the output is 0, 0, is it a valid or not? We need to find based on whether D0 is 1 or D0 being 1. So what is this block? What exactly this priority encoder? What we are writing is priority encoder. Whatever we are saying, I need to investigate what is there in this box. So what is that? That which there is, this is hardware. Okay. This is D2 plus D3. D2 bar. This is D2 bar plus D in AND operation plus D3 will give you Y. So we will get Y, we will get X, okay, we will get V. So this is what exactly I can say, that this is the hardware that is there in priority encoder. So what exactly the input output relations so far we have seen are valid, are going to work if I use this is being your hardware. With this I can say what is priority encoder, what is the need for priority encoder, how to design the priority encoder is being covered.